Okay, everybody, let's talk about this division and remainder. Okay, it is this one. I'm doing this one. So Python provides three operators related to division. The primary division operator is a single forward slash. It always gives you a floating point result. Okay, and another one is this double forward slash. This is called integer division. That means it gives you a quotient, the integer quotient. It doesn't care about the remainder, the continued division. And this is the remainder. This will give you the remainder, the leftover. Okay, let's look at this. So this is, you understand this, okay? And now people is equal to 125, table seats is 8. And we do tables needed float, people divided by table seats. This will give you what? This will give you actual uh, the actual quotient, the actual result. Okay, I'm thinking about this. Let me go here and I will do it so that you can see. Okay, so we want to do what? 125, that's people, and divided by 8, right? So we will do, oh, let's do this. Okay, so 125 divided by 8. Remember, we are using the one forward slash, so that's the real division. And there is 1/8 in this, and then you have 4, 5, and then you have 5, right? Okay, so that is the quotient right there, but we continue. So you continue to do that, and then you have 6, right? And then you have 2, and you continue, and then you have 2, and then you have 4, and you continue, you have 5. So that is your real quotient. Now, the real result, division 15.625. Okay. And that's what that will give you. This one, at the same time, is on the other hand, not at the same time, on the other hand, this one will give you the integer division. So what does that mean? That means you are doing 125 divided by 8. It has 1, 18, 12, and then 45, you have 5, that gives you 40, and that's it. There is not enough in 5. There is not enough in 5. No, there is not an 8 in 5, right? So that's not enough. We stop there. This is the quotient, okay? So that's that. That's called integer division. It only gives you the quotient, the integer. And this one is called the remainder. Remainder is basically division, but you are looking at the remainder, which is this one, the leftover. That is this operation. Okay, so that will give you 5. Let's see. Let's run. And you can see the first one, which is this variable, it's assigned to this variable. It gives you what, 15.625, right? This will give you the quotient, that is 15. And this one will give you the remainder, that's 5. Okay, that's what that is. Now let's look at this one. This is splitting. And so for this print function, you have how many arguments? 1, 2, 3, 4, 5, right? So splitting, you have splitting here, and 358, 358, and by digit, 35. That comes from this arithmetic expression, right? Arithmetic expression. This is integer division. So 358 divided by 10. Oh, did I not do this? Oh, 358 divided by what? 10. So you have 3, and 58, you have 5, right? So that is the integer division. That's why you have 35 there. And then the leftover, is 50. That's 50. The leftover is 8. Okay, so that gives you 8. So these are two arguments, uh, and each one is an arithmetic expression. Okay, so let me just give you some more ideas about this, because this division and remainder are not very easy to understand. You are not familiar with them. So I'm going to do more examples. For example, 11 divided by 3, right? That will be 11 divided by 3. That will give you the real number. So you will have 3, and that's 9, that's 2, and you continue, and you put a 0 there. That will give you 6, and 18, and 206. You will continue to have 3.66666, etc. So that's the real division. Now we will do integer division. Okay, integer division is 11 divided by 3. Remember, we only need the quotient. So 3, that's 9, and you have a 2. So that is the result, right? Now let's do 11 modulus, or remainder 3. You can call it modulus, you can call it remainder. Okay, so 11 divided by 3, that will give you 3, and that gives you 9, 2. And this 2 is not enough for another 3. So we stop there, and that is the remainder. Okay, that is that. So now let's look at this. How about 3 divided by 11? What is that? Since this 1 forward slash, it's the real division, it gives you the accurate result. This will give you 0.2, and then you have 8, and then you have 7, right? So you continue that way. This will give you 0.27, etc. How about this one? 3 integer divided by 11. Okay, let's see. 3 integer divided by 11. There is not enough in 3 for 11, so we put a 0 there, and that's it. So the result for this is 0. 3 divided by 11, integer division. How about this? And by now, I think you already know, right? 3 divided by 11 is not enough. You have a 0 there. And then this is the remainder. Okay, so when you do remainder, if the first number is less than the second number, then the remainder is the first number. When you do integer division, if the first number is less than the second number, then the result is 0 because it's not enough. Okay, for example, 95 modulus 100. What's the remainder? 95. Because it's not enough, right? So you have a remainder of 95. And what if you do 95 integer divided by 100? That is a 0 because there is not enough. Okay, that is division and integer division and modulus or remainder and the real division. Okay, so that's that. Now I want to show you about this function. Round is simply a function. It has one argument. It rounds a number up and down. For this one, it will round it down. You all know that. Okay, so it will give you 12. But if you do this, let's see, if I use a number here, let's use that variable. Okay, I will type tables needed float. Table needed float, right? Okay, let's do that one. And it says table needed float is not defined. What that means usually is that it cannot find that variable. It doesn't exist. And when that happens, and you are pretty sure I do have that variable, the problem is always misspelling. So if you go back, okay, if you go back, go back and look at it very, very carefully, you will see that this is tables, not table. So you always need to pay attention to those small details. Okay, so now it will run and it will give you 16. So this is what? Let's go up. So this is 15.625 round up, that's 16. That's the round function, okay? So for this print, the argument is a function call to round. So now let's look at these two, okay? I want to look at these two. This is assigning a real number, a float, to a variable, and I want to print it out. And here, this str is a string. It's a function, right? It's a data type, but at the same time, it's also a function. And this function is to convert a number into a string. So profit is a float. It's converted to a string. And so now this whole thing is a string. And you are concatenating this string with this string. That's what this is doing. And let's run. And it will give you this, the dollar sign concatenated with a string version of profit. Okay, so how about this? If I don't have the string function, if I do not make it into a string, this will not compile because you cannot concatenate a number with a string. Okay, you can only concatenate a string with a string. So this will not run. What if some of you may say, how about I just separate them, right? When you separate them, remember, there is always a space added to it. And so here you have a space. And in this situation, it looks good. But in other situations, you do not want that space. You definitely do not want the space. So how do you solve that problem? You convert a number into a string. Okay. But I want to make sure you understand this conversion is temporary. That means this 123.56 is temporarily converted to a string. Profit itself, it's still a float. Okay, that is something you must remember. Profit is still a float. It's not a string. Here, it's converting the value in profit into a string. It never changed the data type of profit. That's something you need to remember. Another thing I want to show you is this. Okay, let's print it out. An expression, and you learned this is the multiplication, right? And this is the exponentiation. So the power. So if I do this, okay, this is 3 times 3. That's 9. That will give you a 9. But if I do this, okay, in this case, in operations, the association when they have the same level, because no, this is not the same level. I'm sorry. When they have the same level, you do from left to right. When this exponentiation has a higher level, okay, it has a higher priority or precedence, you will go from right to left. So you will do this first, 3 to the power of 3, that gives you 9. And then you do 3 times 9, that gives you 3, 9, 27. Okay, so let's run. And you can see, oh, 81, 3 nines. Oh, 3 times 3 to the power of 3. I'm sorry. This is 3 to the power of 3. That gives you 27, right? 3 times 3 is 9, and 3 times 9 is 27. So this gives you 27, and then you will do 3 times 27. That gives you 81. Okay, once again, we have to be very careful. This is 3 to the power of 3. That is 27. So mainly I want to tell you, when you have a mixed arithmetic expression, you follow the precedence rule. That is pretty easy to understand. And you can look at this exercise and do it on your own. Okay, so when you have a multiplication and exponentiation or power always has the higher priority or precedence. So you need to do this first and then use that result to do the multiplication or division or whatever. Okay, that's it, everybody.